Understanding irrational numbers, exponents, and scientific notation helps you make sense of the huge and tiny numbers we see in science and in everyday life, from measuring microscopic cells to tracking distances in space. These 8th grade ideas also help you recognize patterns and solve problems more efficiently. In this lesson, we'll break everything down so you can use these skills with confidence. Before we dive into solving equations or working with exponents, it's important to understand the basic building blocks of algebra. Variable. A symbol, often a letter, that stands for a number. In the example, 3x plus 4, x is the variable. Algebraic expression. A combination of numbers, variables, and operations that represents a value. For example, 3x plus 4. Like and unlike terms. Like terms have the same variables raised to the same powers, and they can be combined. For example, 3x and negative 2x are like terms because they both have the same variables x raised to the first power. 3x and x squared are unlike terms because the variables are not raised to the same powers. Evaluate an algebraic expression. To find the value of an expression by replacing variables with numbers. For example, if x equals 3, then 2x plus 5 equals 2 times 3 plus 5, or 11. Next, we learn how to solve equations by using operations to isolate the variable. Equation. A number sentence that shows two statements are equal using an equal sign. Inverse operations. Operations that undo each other. Addition and subtraction are inverse operations, as are multiplication and division. We use inverse operations to isolate the variable when solving equations. Linear equation in one variable. An equation with one variable whose exponent is 1. They can be written in the form ax plus b equals 0, where x is the variable and a and b are numbers with a not equal to 0. Solution or solution set. A value or values that make an equation or inequality true. For example, the equation 2x plus 3 equals 11 has a solution of x equals 4. Addition property of equality. Any value can be added to one side of an equation as long as the same value is added to the other side. For example, take the equation x minus 5 equals 10. We can add 5 to both sides of the equation to get x minus 5 plus 5 equals 10 plus 5. Simplifying isolates the variable x, giving us x equals 15. Multiplication property of equality. Any value may be multiplied by a side of an equation as long as the same value is multiplied by the other side. For example, 2x equals 5. If we multiply both sides by 1/2, we get 1/2 times 2x equals 1/2 times 5. Simplifying isolates the variable x, giving us x equals 5/2. Additive inverse. Two numbers are additive inverses if they add to 0. For example, 5 and negative 5 are additive inverses, as are negative 7 and 1/2 and 7 and 1/2. Multiplicative inverse. Two numbers are multiplicative inverses if they multiply to make a product of 1. For example, 7 and 1/7 are multiplicative inverses, as are negative 3/4 and negative 4/3. Exponents and radicals let us write repeated multiplication and roots in a simple way. Exponent. A shorthand way of writing repeated multiplication. In the expression 2 to the third power, the exponent is 3. It tells us how many times the base is used as a factor, 2 times 2 times 2. Exponential notation. A way of writing repeated multiplication using exponents. For example, 2 times 2 times 2 equals 2 to the third power. Properties of integer exponents. Rules that help us simplify expressions with exponents. Product rule. Multiply powers with the same base by adding exponents. X squared times x to the third power is equal to x to the fifth power. Power rule. To raise a power to a power, multiply the exponents. 2 squared cubed is 2 to the sixth power. Power of a product rule. Raise each factor to the power. xy to the third power is the same as x to the third power times y to the third power. Quotient rule. Divide powers with the same base by subtracting their exponents. X to the fifth power divided by x squared equals x cubed. Power of a quotient rule. Raise the numerator and denominator to the power. X divided by y cubed is the same as x cubed divided by y cubed. Negative exponent rule. X to the negative n power is the same as 1 over x to the n power. Zero exponent rule. X to the 0 power equals 1 for any number where x does not equal 0. Perfect square. A number that is a square of an integer. For example, 16 is a perfect square because 4 squared is 16. Square root. A number that when squared equals the original number. For example, the square root of 16 is 4. Perfect cube. A number that is a cube of an integer. The first 5 perfect cubes are 1, 8, 27, 64, and 125. Cube root. A number that when cubed equals the original number. For example, the cube root of 27 is 3. Radical. A symbol that looks like a check mark used to represent the root of a number. Numbers can be classified based on how we can write them. Some numbers are rational, while others cannot be written as simple fractions. Decimal expansion. Writing a number in decimal form. For example, 1/2 equals 5/10. Rational number. Any number that can be written as a fraction, a over b with integers, and b does not equal 0. Rational numbers include all fractions and decimal numbers that terminate or repeat. Irrational number. A number that cannot be written as a simple fraction whose decimal value goes on forever without repeating. For example, pi and the square root of 2 are irrational. Very large or very small numbers are easier to work with in scientific notation. Scientific notation. A way of writing numbers as a product of a number between 1 and 10 and a power of 10. For example, 4.5 times 10 to the third power equals 4,500. Significant digits. The digits in a number that carry meaning about its precision. In 4 and 506 thousandths, all 4 digits are significant.